How are we doing? I know this is a bit of a pop-up, so you're probably going to watch this recorded, which is absolutely fine, but stay tuned for this. This is going to be some feedback on the practical paper, which is still probably the part of the A-level which is done least well. So in Edexcel, that's paper 3, and this is feedback from the 2018 kind of so do go through this, because this is the type of thing they're going to make sure they're testing heavy on the next year's papers as well. Okay, my kids have just done these as a mock exam, and so it'll be really useful for them. But this is really useful for just any exam board, because these type of skills come up in every single A-level physics. Very, very Merry Christmas for you. If you're a GCSE student, then this is probably not going to be all that interesting for you, unless you're going on to A-level next year and you're interested to know about this practical paper. I'm just going to run through loads of things that people are doing not so well or well, and make sure that you know where you can work on to make sure you're doing better than everyone else. Every single year, the responses to these tests get better and better and better as people practice more and people make sure that they're able to do things. So do also give me a thumbs up on this video. Do also give me a like and a subscribe as well if you're not subscribed already, and make sure you've got the notifications on. Right, so paper 3, it tests indirect practical skills, and that's something that people aren't doing very well. They're learning all of the core practicals quite well, but they're not bringing those same practical skills into any kind of situation. So that's something to focus on. Yes, know the practical skills, but know that those practical skills get transferred into any practical they might give up. Okay, they might come up on the paper. Linking points is not done very well. So saying this thing happens, therefore this thing happens, is not done very well. People are just saying this thing and this thing, but they're not saying that causes that, or that's because of that. And actually that linkage is an important idea and doing a coherent answer in the correct kind of order, an order that makes sense, this thing, then this thing, then this thing, rather than just shoving down bullet points. And that's when you see the little asterisks. That's when it's going to be marked on your quality of written communication as well. Also, synoptic and synthesis questions, where you're actually having to bring together different parts of the syllabus, is not done very, very well. So I urge you to find those 3 types of questions and practice them loads. Hi, yeah, Luca, and practice them loads. That is indirect practical skills, so not just your own core practicals or required practicals, but also applying that to any kind of practical that might come up. Those skills that you have to be able to do to any kind of practical. Linking points together in your explanations, and also synoptic and synthesis, so bringing different parts of the syllabus together to actually make an answer. Right, so then now I'm going to give loads of kind of specific feedback, and then I'm going to tie up with just some kind of key areas that you can think about and work on. So superficial responses, people are giving responses that are just kind of skimming the surface. They're not really delving into the physics theory that explains and underpins the answer they're trying to give. So they might be getting on the right idea, but they're not really giving the deep theories. Actually, people are looking to just giving conclusions rather than using evidence to support conclusions. Science is about evidence supporting conclusions. So make sure that you give conclusions, what your evidence is. And that's often going to be making comparisons with numbers. This is bigger than this, or I've calculated this, and that's bigger than that, so that's the answer. Okay, actually answering the question, Lewis had made a video, Lewis from A-Level Physics Online, called RTFQ, which is really, really important. Check that your work that you're doing is actually a response to a specific question, not just chucking down any old key points, but actually answers the question actually answers the question that they've given you. This applies to all exam boards, but this is specifically from Edexcel. But I think it's definitely useful for AQA A-Level Physics. It is useful for GCSE as well. The term voltage is not really accepted as potential difference, okay? So think about voltage has 2 kind of ideas. EMF, that's if it's an open circuit, so you haven't plugged anything in yet, that's the EMF. It's the theoretical maximum voltage from a cell or a power source, or the terminal potential difference. That's what you get across what you are powering by the power source, okay? So don't just be using voltage anymore, okay? That's not really acceptable. You understand the difference between an EMF and a potential difference. Also, there's a bit of a misunderstanding about whether you use decimal places or significant figures in your results, right? Well, some meters can only use 2 significant figures when the number's really small, okay? So it might be 0 point something something. That would be 2 decimal places. So you would give that to 2 decimal places. But later on, that whatever you're measuring might increase above 1. So that'd be 1 point something something. So that would still be 2 decimal places, but now it'd be 3 significant figures. So that would be acceptable. You can write that down. You can write down a different number of significant figures if it's something that's been measured. But if it's been calculated, you should stick to 3 significant figures. So you don't use decimal places once you've then used that number to make a different number. So if you measure something, use decimal places, keep the same number of decimal places, whatever decimal places your meter measured to, basically. And when you've calculated something, you stick to the same significant figures as the least number of significant figures you have of your data. I hope that helps in the difference between decimal places or significant figures and why we use them. Use of the terms accuracy. Accuracy is how close is it to the truth. Error means something's gone wrong, and there's a difference in error and uncertainty. Everything we measure has an uncertainty, but it's not necessarily you've done something wrong. And errors can either be random or systematic errors. So group them in those 2 areas. That's an error. Something's gone wrong. Precision is not the same as resolution. Precision means how spread out are your results. Resolution is the smallest thing you can measure on your scale. So sometimes resolution can give you precision, or sometimes your precision can in fact impact your resolution, okay? Or the choice of instrument based on resolution can affect your precision, but they're not the same thing. Precision is about the spread of data, resolution is about the scale. Okay, and I've already said this a couple of times, applying skills and knowledge to novel practical situations. So you've done all those core practicals and you've learned all the apparatus and techniques in there, all the different things that you have to be able to do, and then you've got to apply them to new situations. That's what you need to really practice there, okay? I will stop for a little bit of chat at some point, but I just want to bang through this and then we can have a little chat if there's anyone hanging about at the end, if you've got any questions for me, okay? Where do we get up to? So yeah, learning definition of key terms, right? In this paper, there's loads of times where it's asked you to explain something, and the first 2 marks, you didn't even need to explain it at all. You just need to be able to define 2 things in the question. So make sure that you actually put down some accurate definitions of key terms. You can pick up marks. Then make sure you relate that definition and that idea to the actual context that you've been given in the question. So that's going back to the idea of answering the specific question. So you've defined a couple of things, you've got a couple of marks for that without really having to understand what the question's really getting at. You've just defined a couple of terms, but then actually applying that to that context and using those definitions to explain the context, that's going to get you those extra marks. Really, if you can get like half marks, you know, on some really tough questions, then you'll probably be doing right at the end of the paper. Yeah, things like normal. Sorry about that. So how to calculate like the volume of a cylinder and things like that. Those kind of normal mathematical expressions, you need to make sure you're able to use them at any kind of point. Also, when you're considering which instrument to select, think about the resolution. Sorry about this, but I'll just crack on. I think you're going to measure uncertainty based on that resolution as an estimate for uncertainty. Moving on. So always estimate. You calculate a percentage uncertainty. You don't need to give loads of significant figures. Just 1 or 2 is fine. So roughly 7% uncertainty or roughly 7.5% uncertainty. You don't need to give us loads and loads of significant figures. It's not a calculation, it's an estimate. Okay. Really, again, remember to answer the specific question. Don't just put down some information that might be related. Make sure you relate it back to the specific question. I think one of the examples, whether you were talking about absorbing a photon or emitting a photon, make sure that you're giving absorbing a photon or emitting a photon. Make sure that you're giving the correct discussion. People not even knowing how to use the basic, like instruments like ammeters and voltmeters, making sure ammeters are in series and voltmeters are in parallel. It seems really obvious when you're just doing it in class, but make sure that under the pressure in the paper, you're getting them in the right place, all those basic stuff. And similarly, basic stuff like remembering to express using the correct SI units. Now, I actually made this mistake, okay, I'll be honest with you. I was calculating some density, we were doing density of sweeties in the lab just the other day, and I did one length in millimeters and height in centimeters, and I'd multiplied them together with another one, and I got something wrong, right? So it was when we actually looked at the data and I realized, actually thinking about that, 13 grams for a centimeter cubed or something? No, that's too big for a sweetie. So that's when we could look back through the data and realize that I'd made a mistake on the SI units. So check, is your answer sensible, right? and actually, you know, make sure, just go back through, work back through your maths, use the time that you got in the exam to work back through your maths and check all the little things you might have got wrong. Get used to what you generally get wrong. I'm a bit sloppy with maths at times, and that's something that I generally get wrong. Powers of 10 are where I tend to make my mistakes. Again, the number of significant figures in your answer should reflect the raw data. There's no point in giving more significant figures than your raw data, because you don't know, even though that divided by that gives you 3 recurring, you don't need to give all that because you don't know it to that precision. So there's no point in giving it to that. So you give it to the same significant figures as you were given in your raw data. I think that's really, really important. If you stick to 2 or 3 significant figures in your answers, then you're probably never going to make a mistake. But don't give way more significant figures or just 1 significant figure in your answer. Okay. If you're thinking about making things equal to another thing, right? So things like energy analysis, things like nuclear equations where you've got mass lost, then write out like a word equation or write out a symbol equation that makes sense to you, so you can get your head in the right idea, in the right place about, you know, what quantities go where. Okay, and one of the things about this was about energy transfers. This form of energy transfers into this form of energy. If you just write that kind of simple word equation, then you put your equations for those sources of energy, then you can make sure that you're getting them on the right side of the equal sign. That makes sense? And in A-level, it's probably going to be not just one store and another store, it's probably going to be several different stores. So you need to make sure a pair of them are on the right side and the right ones on the other side. Okay, and if you do that, if you think, oh, that energy is going up, that energy is going down, then you're going to get them on the right side of the equal sign and hence do your calculation correctly. And the last one, the general points, the more specific points, is make sure if you use an equation in your answer that you actually define the symbols unless they have already been given in the question. So if it talks about, you know, the force, then you can write F and we'll presume you're talking about the force, right? But if it doesn't talk about the force in the question, when you write F, you need to state that means a force, right? Okay, so the key bits, the general feedback you can also do is make sure that you're answering the question, not just putting down something that's randomly related to that area of physics. Answer the specific question, RTFQ. Read the question. Okay, very, very important. And read it again once you've answered and check you've actually related to that context. Work final answer and work back through and check that you've been in those same SI units throughout. Plan your answer. When you're doing a longer written one, think about your physics ideas, and then you're hopefully going to be able to write it in a coherent and logical sequence if you just think before you write. Loads of people start, well, let me tell you about this theory. And they've already used up 2 or 3 lines before they've even put anything relevant down. So make sure that you actually think through this logical kind of sequence of your answer that you're going to go. And always learn standard definitions and standard explanations that come up time and time again in these exams so that you can use them as kind of ammunition to actually tackle the question that you've got in front of you. All right, I know that was really, really quick, but I'm tired. I'm sure you're tired and it's time for holiday. But I just said I was going to do this before I said I was going to do this before the holiday, so I feel good that I've actually got this out for you guys and that you have some ideas of what to practice before you do your practical papers. So an off-topic question about Newton's laws. Does Newton's laws work with general relativity? I think that within any specific reference frame, Newton's laws apply, but not necessarily across reference frames, okay? You don't particularly learn about general relativity much in A-levels, just kind of touch on some of the tenets of it, really. Can you please make an index? All right, Mouss law and waves polarization. Mouss law is something to do with, I believe, like the rotation of the plane polarizer. I will have a look at it. I'll think about that in the new year for you, Wasif. Okay, it's not something that I know too much about. Difference in EMF and voltage. Well, don't think about it as being voltage or EMF. Those two quantities, EMF and potential difference, are measured in volts, so they tend to be muddled and you use the word voltage, and we'd accept that at GCSE, but not really at A-level. EMF is like the theoretical maximum, I said voltage, theoretical maximum number of volts you could get out of a power supply before you plugged anything in, right? But always, once you have plugged it in and you've got a complete loop, you dissipate some of those volts through the actual internal resistance of the thing. So the EMF is what we say the terminal PD in an open circuit. So we haven't actually connected anything. As soon as we're drawing a current, then you're also going through the internal resistance of the power supply. So the terminal PD is the actual potential difference, the difference in electrical potential between 2 points on either side of your component that you're actually working with. So the terminal PD is what you actually get for to run your thing, run your component. I hope that helped. If you just arrived, then make sure you go back, guys, and go all the way through this video, because there's some really good points that you need to make sure you're doing for the practical papers. And just for Luca here, probably the same in the different examples. What is the same is the apparatus and techniques. So the actual apparatus you need to know about and how to use that is the same throughout all exam boards, right? So the errors that people will be making in one will be similar to the errors people will make in the other. So you can learn just those apparatus and techniques. All the different exam boards have made a set of practicals to meet those apparatus and techniques. I hope that makes sense. So actually, if you learn one exam board's practicals, you won't know by heart the practicals for the other exam boards, although they'll be quite similar, but they will use the exact same apparatus and techniques, which is the kind of meat and veg of these practical papers, and they're all the same throughout the different specs. I can't just use the left and right hand rules properly, I just don't understand them. So we motor on the left, right? So motor effect is your left hand, and there's F, B, and I. Force, field, and current, right? And essentially it's just a way to work out the direction. If you know two directions, then you can work out the third. So that's the motor effect. We motor on the left in Great Britain, we drive on the left. Okay, so that's the motor effect. The generator effect, okay, if you like, the dynamo effect, is a way to work out if something is moving through a field, it's a way to work out what direction the current is. But again, if you know two of these directions, then you can work out the direction of the third. So just remember that motor on the left, remember what your fingers mean, and practice orientating it in the different possible ones. You too, buddy, have a good one. Practice orientating your hand in those different available options. Okay? Hope that helps. Could you make a video on the ultraviolet catastrophe and what actually is Planck's constant and why is it there? So off the top of my head, is it joules seconds or Planck's constant? It's just a constant that relates the energy in a photon to the frequency. So E equals HF, which is often a point. If you're doing quantum, one of the things you should refer to is E equals HF, or going to say something motivational. Yes, one of the things that is often coming up in in quantum questions is, well, how is the frequency related to the energy? And make sure that you're either talking about the frequency or the energy. They're proportional to each other. So if you double the frequency, you double the energy of the photon. And the number that governs that change is just like a conversion factor, really, between the frequency and the energy is Planck's constant. I hope that helps. What was that? What was the rest of that question? I thought it was quite interesting. Ultraviolet catastrophe. Yeah, I can do a little bit. It doesn't come up in Edexcel, so it's not something I know loads about. I know that Lewis at A Physics Online has a fantastic video about ultraviolet catastrophe. I also know that Dr. Physics A, who is one of the original physics YouTubers, has a wonderful video on ultraviolet catastrophe as well. So I'd say check that one out. Come back to me and ask me again, and I'll see if I can put something together for that. Something motivational. Let me think. Well, it's Christmas, right? So what I want you all to do is I want you to finish watching this video, have a little think about maybe your mock exams, a bit of time just reflecting on what you did and didn't do well and how you're going to improve your study for the next set of mock exams, and then the real thing, what you're going to learn from these mock exams you've just done. Hopefully you have been fed back. If you haven't, then just think about what you felt went well and what didn't, and then just have a good rest, right? We have holidays in schools, big long holidays, because we all get tired in schools. It is hard work. Learning is really, really hard work. And I know that you guys, put in a lot of effort, and you'll hear like most people have gone home and collapsed. And loads of kids would say, oh, I'm just going straight to bed when I go home. I just need my bed, And I feel like that a little bit as well, but right, it's worth it, okay? You're here because you want this. You want to get good GCSEs and A-levels. You actually want to do well, you actually want to learn the stuff. So I don't think you need any motivation. I think you need a rest now, dudes, okay, right? So I'm just gonna say like Merry Christmas and Happy New Year, unless there's any other chat. I just think that you ought to stop now, just kind of sum up this term, have a little reflect, and then park it. And then in the new year, when we go back We go back and your schools probably have like an inset day where they go and do what they're training and you don't have to go to school. Make that your first 2 days to pick it up and think, oh yeah, I was thinking about that. I was struggling with that area. What do I need to do what do I need to do to improve myself? What do I need to do to improve the next step? And just sort of pick it off, yeah? Don't think like you don't have to be ready yet. You don't think like you have to be able to answer any question in GCSE or A-level physics right now. You don't. You have to do that in June or whenever your actual exam comes up. What you need to do right now is you need a break. So have a really good Christmas and New Year. Don't feel guilty about spending like an entire week not even thinking about school. Get that game completed, whatever's coming next, okay? Get that book read, get that instrument learned, go out for walks with your family, whatever you enjoy, right? Get back into your hobbies, because now's not the time to make the different things. Now's the time to reset your brain and get over this long term that we've had. And think what you just make that little list for yourself. What are you going to do differently next term? Park the thinking and get back on it. Yeah. We've got a couple more things. So GCSE, how much do you reckon you study every day? Like weekdays, like maybe 1-2 hours, and then nothing over the weekend. I'd say if you're doing GCSE right now. And that's a really good way to think about it, really. Because I know you've got 11 subjects, but don't overdo it. All right. If you're working hard and you're watching these videos and everything like that, then count these into your study. But the most important thing, Matrix ones, is not how much you're doing, but it's what you're doing and why you're doing it. It's like thinking, oh, I don't get that area, so I'm going to spend a bit of time on that, rather than stressing out about the actual volume that you're doing, but it's like what and how you're doing it. I hope that helps, bud. What we say is the best way to understand the concepts. The way I like is actually doing this, yeah. So actually, I'm not suggesting you live stream on YouTube and try and explain things, but actually try like explaining stuff to the camera. Record yourself, watch your back, and then when you the nerd, think about how you would improve that, and then like say it all again. Okay, and actually saying it out loud forces you to really, really think. Do I understand it? Could I explain this to somebody who doesn't really know much about physics? If you can't explain it in a simple way, this is a Richard Feynman technique, so what he said, if you can't explain it in a simple way, you don't really get it. So if you can work out, if you can get to the point where you can explain all these difficult concepts in a simple manner that anyone could understand, then you're gonna understand it deeply yourself. I hope that helps. Try explaining it to your mum, try explaining it to your dad, try explaining it to your cat or your little brother or something like that. Just try explaining it, and that's the way to make sure you understand. And what's the best tips to revise? Absolutely loads of tips to revise all over my channel, so if you have a little look at those. I say my favourite one would be that, but whatever you do to revise, be active, don't just sit and write stuff out. So make sure you actually like, doing something with it, not just making like a poster or something. A lot of people think, oh, that's active, I'm making something, but it does end up to being that just kind of copying out kind of thing. But I'm going to go because I need to clean this room, so thanks a lot for watching, dudes. Can you hit the like button for me, please, so that everyone knows this video is worth watching? Active recall is definitely the thing, but how do you learn new content but not ignore the old stuff? Again, that's kind of bulk revision, making sure you're revising over the whole topic at once. All right, dudes, see you later. Have a good Christmas and New Year, everyone. I really appreciate you on this channel. Okay, thanks.